Online maps enable sighted people to access a large amount of spatial information, especially by panning and zooming. On the contrary, tactile maps are static, and can only present a limited amount of information. By designing non-visual pan and zoom maps, we could provide visually impaired users with an access to large maps. In this project, we address the following questions. Can visually impaired users understand pan and zoom maps? How to design interaction techniques for non-visual panning and zooming? To do so, we designed BotMap, an actuated tangible interface that enables visually impaired users to explore pan and zoom maps. BotMap is composed of a large horizontal screen that displays a subpart of the map. Small robots, which are around 2 centimeters in diameter and 2 centimeters high, are placed on the screen. Each robot represents a landmark that the user can interact with. Whenever the map is updated, the system computes which landmarks must be displayed and the robots move accordingly. Once the robots are in place, the user can retrieve the name of the landmarks by placing on top of the robot's one finger that is tracked by a camera.
Johannesburg, Nairobi, Cairo.
We designed 2 interfaces that enable users to center a landmark, zoom and pan.
Dakar.
To center a landmark, users must select the landmark and say center. Here, the user is centering the viewport on Dakar, before zooming in. Users can switch between 3 zoom levels to display more or less details. For example, in this video, the 3 zoom levels are metropolises, cities and towns. Users can also pan the viewport over the map to explore it. The keyboard interface supports discrete control. A numeric keypad is placed on the right side of the screen. When panning, users can move the viewport using step-by-step movements by pressing the arrow keys. Feedback concerning the position of the viewport on the map is given accordingly, using clock face directions.
12 o'clock, 3000, 12 o'clock, 6, 12 o'clock, 9, 12 o'clock, 6, 12 o'clock, 3.
When zooming, users can select 3 predefined scales, 1 per zoom level, by pressing the plus or minus keys.
Metropolises, cities, towns, cities.
The sliders interface supports continuous control. 3 20 to 30 centimeters long rectangular areas, delimited by cardboard, are placed around the map. A robot can be moved inside each area to control the horizontal and vertical position of the viewport, or to adjust the scale. When panning, the viewport can be moved in any direction and distance. By moving the horizontal and vertical sliders located below and to the left of the viewport, feedback concerning the position of the viewport is given every 2 seconds.
12 o'clock, 9. 12 o'clock, 6.
When zooming, any scale can be selected by interacting with the slider on the right of the viewport. We conducted 3 user studies. Results show that the 2 interfaces enable users to not only explore pan and zoom maps, but also to understand them. We also gathered feedback on the use of robots for non-visual actuated tangible interfaces, as well as on navigation aids.